All right, welcome to the quarter two exam. Exam review, I'm sorry. I'm going to go through this fairly quickly because there's a lot of problems. So top of the fraction is x plus 5 times x plus 5. On the bottom, we need to factor. First thing we're going to do is pull out a greatest common factor. Both terms have an x. Both terms are divisible by 2, and we'll end up with 2x times the quantity x squared minus 25. But this bottom part here will in fact factor, so I'll end up with x times x plus 5 times x plus 5 over 2x times x plus 5 x minus 5. And then I'm just going to cancel the x plus 5, so I'll cancel the x's, and I'll be left with x plus 5 over 2 times x minus 5. And that's our final answer. For this one, it's asking us to add the two fractions, so the key thing here is to find the common denominator. The common denominator of 5 and 10 is going to be 10, and they both need to have an a. So the common denominator is going to be 10a. This is already 10a, so I need to turn this into 10a. So I'll rewrite my fractions down here so we can see what's going on. In order to turn 5 into 10a, I'm going to have to multiply it by 5a. But I have to multiply the top and bottom by 5a so that I'm really multiplying it by 1 and not changing the value of the fraction. And I'll get 20a squared. I'm sorry. That should be 2a. I should do these a little slower so I don't make mistakes. I apologize, ladies and gentlemen. 2a. There we go. That'll give me 8a squared over 10a plus 9b over 10a, or 8a squared plus 9b over 10a. And there's our final answer. All right, for this one, simplify, so we want to factor the top and the bottom. The top, I'm looking for two numbers that multiply together, give me 9, that add up to negative 6. And those numbers are negative 3 and negative 3. The bottom is a difference of squares, so that's going to be x plus 3 times x minus 3. I will cancel my x minus 3s. I'll end up with x minus 3 over x plus 3. And that's the final answer there. All right, this next set of problems asks us to factor these. So once again, our first step should always be to pull out the greatest common factor. So if I pull out a 3, I'll get 3 times 2x squared plus 3x minus 2. Now, there is a number in front of the squared term, so I'm going to have to use the AC method. And that is, AC is negative 4. So I need two numbers that multiply together to give me negative 4 that add up to positive 3, and that's going to be 4 and negative 1. So this will be 3, 2x squared, and then and there is, we split the 3x into two pieces there. And then we're going to just group the terms. Out of the first one, I'll be able to pull an x, and that'll leave me 2x minus 1. And out of the second one, I'll be able to pull a 2, and that'll leave me 2x minus 1. So this will be 3 times x plus 2 times 2x minus 1. This is just a difference of squares, so we're going to end up with terms like that, and one will be plus and one will be minus. Just remember, 9 is a perfect square, z squared is a perfect squared, y squared is a perfect squared. For this one, remember the first step is to always pull out the greatest common factor. All three terms are divisible by 3. All of them have an a, and all of them have a b. And what I'm left with is 5a minus 3b squared plus 4. And the part here in parentheses is now prime, so that's my final answer. That was just all you had to do there was pull out the greatest common factor. For number 7, this is going to be another AC problem. AC is going to be 30. So what are the two numbers that multiply together give me positive 30 that add up to negative 11? And that's going to be negative 6 and negative 5. So this will be 2x squared minus 6x plus negative 5x plus 15. We split the negative of 11x that way. Group the first two, group the second two. And when I pull out the first side, out of the first set of parentheses, I'll be able to pull out a 2x. And it'll leave me with x minus 3. Now here's the key part, is that I'm going to need what's going to be in parentheses over here to be the same. This is a positive and a negative. And right now in parentheses I have a negative and then a positive. Now I can pull out a 5, but in order to switch the signs I'm going to pull out a negative 5. And you're going to have to pull out a negative when both terms here are negative. And I'll end up with 2x minus 5 times x minus 3. For number 8, I'm looking for two numbers that multiply together to give me 64 that add up to 8. And I'm just going to list all the factors so you can see this. 4 and 16. And then 8 and 8. So those are all the things. What you'll notice is that none of them, if I add up to 8, so this is prime. We have to check to make sure. All right, so this is what's known as a difference of cubes. And remember, all the cubes have the same form, sum and difference of cubes, which is you got a, b, and then you got a squared, ab, and b squared. And then the signs go in by SOAP. And since this first sign here is negative, that's the same, opposite, always positive. So that's going to be my form here. And so, I'll leave SOAP written up. So the question is what are the cubes? So what's being cubed to get x cubed is x. What's being cubed to get 8? And that's 2. And then we just write in the other pieces. The first term squared, the two terms multiplied together, the second term squared, and then we do the signs using SOAP. Same, opposite, always positive. For this one, once again, these problems are a lot easier as if the first thing we do is pull out the greatest common factor. Because now I don't have to use the AC method because the coefficient of x squared is 1. So now I'm just looking for two numbers that multiply together to give me 8 that add up to negative 2. And those numbers are negative 4 and positive 2. Remember, don't forget, if you have the 3 here, you got to bring it down. You got to keep that 3. Don't drop it. And the last one, this is a sum of cubes. And a lot of times we forget that because we forget that 1 is a perfect cube. But it's going to be 1 and x. And then 1 times 1 is 1, 1 times x is x, and x times x is x squared. And then we use SOAP to get the signs. Same, opposite, always positive. All right, so now we're moving in different type of problems, stuff from early in the year. Give the solution using interval notation, graph the solution on the number line. So remember, if we have absolute value equals a number or is greater than a number or less than a number, that's really two different equations we're solving. Because this could be true, because 3x minus 7 could be greater than 5, but also 3x minus 7 could, negative 3x minus 7 could be greater than 5 or less than negative 5. Remember to flip this when you get the negative. So we're going to have to solve both of these equations. I'll add 7 to both sides. This is 3x is greater than 12. Divide both sides by 3, and x is greater than 4. Over here, I'll add 7 to both sides. I'll get 3x is less than 2. Divide both sides by 3, and I'll get x is less than 2/3. It said do it on the number line and give, where's mine? Oh. So here's my number line. It's going to be an open circle at 4 and an open circle at 2/3. And we'll just go ahead and write it and say 2/3. And we're going to shade down from 2/3, and we're going to shade up from 4. And then it also asks us to give the answer in interval notation. So it's going to be negative infinity to 2/3. Remember, it's a rounded bracket because the 2/3 is not included, with the union of 4 to infinity. And we're describing the two pieces there. The next problem says solve each inequality once again. Now the key here is that we have to get this piece here alone. The absolute value has to be by itself before we can create our two equations. So before we do it, and my trick was to think of it like this. Sorry. And if I solve this, I'd add 3 to both sides, and I get 2u equals 10, and I divide both sides by 2. So we're going to treat the absolute value the same way. I'm going to add 3 to both sides. And I'll have 2 times the absolute value of x plus 5 equals 10. Then I will divide both sides by 2, and I'll get the absolute value of x plus 5 equals 5. Now I can create my two different equations. And when it's equal, it's easy. It's either x plus 5 equals 5 or x plus 5 equals negative 5. We'll just solve both of those. I'll get either x equals 0 or x equals negative 10. Then it asks us to graph it. Now, this is don't have to use interval notation here because it's just a set of numbers. My two solutions are negative 10 and 0. And then if we actually had to put them on the number line, it would look like this. There'd be a dot at 0, and there'd be a dot at negative 10. We wouldn't do any shading because those are the two values that are the solution. All right, what is a root? A root, and this is just one of those random things is that we want to review, is that a root is a solution. It's also sometimes the x-intercept. Because remember, we talked about how x-intercepts give us the solutions to functions when they're set equal to 0. So look at that. Root is another name for a solution or an x-intercept. All right, for number 15, remember that this symbol here means inverse. So it's asking us what is the inverse. So if we have a function like this, the inverse is just switching the x and the y's. So the analogy we used was, it's like Google Maps. It's the undo button. Whatever number you put in, you get a number out. If you plug it in the inverse, it'll take you back to the number you put in. And so now we just need to solve this for y. So I'll add 4 to both sides. And I'll get x plus 4 equals 3y. Divide both sides by 3. And I'll get y equals x plus 4 over 3. So I would say that the inverse of x is x plus 4 over 3. So that should be an x. Smartboard's a little weird on that side. Moving right along. this one, f of g of 8. There's a couple different ways you can do this, but the easiest one is this is f of g of 8. So I'm going to find out what g of 8 is. That's 3 times 8 minus 4. So g of 8 equals 20. So this is really asking for f of 20. And f of 20 is going to be 1/2 20 plus 5 for 15. So f of g of 8 is 15. This one asks for g of f of x. And whenever you see there's an x and not a number here, you're going to get an expression out instead of just a constant. So g of f of x. So what we're going to do is g of x is 3 times whatever I plug in minus 4. But this tells me what I'm plugging into g of x is f of x. So I'll end up with 3/2 x plus 15. But people tend to forget the minus 4. So you'll end up with 3/2 x plus 11. And that is g of f of x. And by the way, just in case you see it, there's another way you can write that, which is that. And that's not golf of x, that's g of f of x. All right, so this is just the example. They want us to give an equation, they want us to give us a graph, and then the domain and the range. And if we've forgotten the domain of the numbers you can put out and the range of the, domain of the numbers you're allowed to put in. Using our vending machine example, that's the currency I'm allowed to put in the machine. Are there limits to what I can put in? And the range is whatever the drink machine is going to put out. So we have to figure out what these functions look like. So the square root function is just we take x and we take the square root of it. And then we had to plot some points. And if you put this in the calculator and go to the table, it's very easy to get a few points. Like this, and what you'll get is a half sideways parabola. So now here's the domain. Remember our technique is we walked along the x-axis, but we can only walk where the function is either above or below us or exists. So the function really starts here at 0. So the domain in interval notation is from 0 to infinity. And I use a square bracket because 0 is part of the domain. I'm allowed to put 0 in. The square root of 0 is 0. The range then is we take our little Peter Parker guy here and we turn him into Spider-Man and we have him walk on the wall. Same rule. Where can he walk? Well, he has to start walking here and he goes up. Now this function goes out faster than it goes up, but it's still going up forever. So the range is 0 to infinity. And once again, this is a square bracket because 0 is an included point in the range. So the next one is an exponential function. We can pick some number, it doesn't matter, and we can raise it to x. And once again, if you put that in your calculator and you get some points, you'll get, when you plug in 0, you get 1, because anything to the 0 power is 1, 2 to the 0 is 1, 2 to the first is 2, 2 to the second is 4, and 2 to the third is 8. But what's really interesting is 2 to the negative 1 is 1/2. 2 to the negative 2 is 1/4. And so you get this curve like this exponential curve. Now the domain is that this is going up, but it's still leaning out a little bit. So it goes up forever, and clearly it goes that way forever. So the domain is negative infinity to infinity. The range, though, is tricky. It's clearly going up to infinity, but what's the lower limit? Well, 0. But do we ever actually get to 0? And this is like in the NFL, half the distance to the goal line. If we keep going and keep going and keep going, we never actually get in. So we're going to get really close to 0, but 0 itself is never going to be part of the range. Quadratic is a simple one. We've seen this here. We should be able to get the points. And remember, it's symmetric. And we get our well-known parabola shape. And once again, the arrows are going up, but they're leaning out slightly. So the domain is from negative infinity to infinity. And the range in this particular case of the one we starts at 0 and it goes up forever. 21 is absolute value. It's just taking the absolute value of x. And once again, if we put in just a positive number, we get out the exact same positive number. But if we put in a negative number, we get the opposite. So if I put in -1, I get 1 out. If I put in -2, I get 2 out. If I put in -3, and we get this familiar V shape. Once again, the arrows extend these directions forever, so the domain is negative infinity to infinity. And the range, once again, the function I drew starts at 0 and goes up to infinity. All right. For these problems, we're going to have to use our calculator. So let's bring up the TI-84 here. Sorry, it takes a second for the software to start. And so let's throw up my TI-84 here. So the first thing we want to do is, well, I want to quit out of this. Sorry, doing some stats there. So we need to find, first thing we want to do is we want to look at the data, because we want to find an equation that best fits it. So we need to look, thinking about our families of functions we just did, what shape does this look like? And so to put the data in, you go to Stat, you go to Edit. We're going to put the data in. So -5, we're going to put in our x's into L1. I think I got messed up there. There we go. And we'll put our y's into L2. Then we need to go to the stat plot and make sure it is turned on. It's going to plot my L's in X1 and my Y's in L2, just like we asked about. So then I'm going to go to Zoom, and I'm going to go down to number 9, which is Zoom Stat. And it should zoom in a picture of the dots. Now, if we look at these dots, we see a pattern where we're going up and then we turn flat and maybe even come down a little bit. And this is not very telegraphed. Generally on the SOL, they'll give you one where you can fairly clearly see the shape. And we can't here, but we see this, and maybe, just maybe, it's a parabola down. And so if it's a parabola, that name of that family of function, as we just saw a few slides ago, was a quadratic. So we go to Stat, and we come over to Calc. And it asks us for all the different regressions we can find. And we're going to find the quadratic regression. And the only extra pro tip here is, you don't have to do this, but it's kind of fun, is if you go to F4, you can actually have it write the equation in for you. And so we go to calculate, and this is our equation. And if we go look at the graph, we can see that that's sorry about the bell. Did I put my data in right? -14, -4, 14, 16, 14, -5, -3, -1, 0, 2. Yeah, so there's my graph of my data. And that's not so awful. So then we look at this, or we can just do this. Go back and have it calculated again. It's already in, so I don't need to have it. And so what I'd do is I'd recommend only going to a few decimal places. So this is going to be it's going to be y equals -0.78 x squared plus 2.10x plus 14.26. And there's our equation. All right, so now we have another data set, and we do the exact same thing over. So first thing we're going to do is we're going to put the data in the calculator. So stat edit 0, 1, 2, 3, 5. -5, -2, 1, 4, 10. And then we want to, stat plot still turned on, so we're just going to go zoom, stat, and whoop, my old line is still in there, so let's clear that out. When we look at the graph, that is very clearly a straight line, and that couldn't be any straighter if we tried. So when we go to stat calc, we're just going to have it choose the line of regression, and I can store this. That's what I want. And then we go to calculate, and we get a very simple equation, which is y equals 3x minus 5. And if you wanted to see, that's very clearly the graph of the function, because if I click on graph, that's it. All right, last couple problems. So for this one, the key to this is remember that if you have f of x, if you subtract c from inside, that's going to shift it to the right, and if you add c, it's going to shift it to the left. And if you have a function, you add something to the outside, that's going to shift it up or down. And inside goes backwards, but outside goes exactly like we thought it would. So if we want to shift 7 units up, we just take our original function, we add 7 just to shift it up. And so we'll get y equals 3/2 x plus 2. And that is the exact same graph, and that's just going to shift it up 7 units. All right. Give the property that justifies each statement. If z minus 5 equals r and r equals 30, then z minus 5 equals 30. And there's a lot going on there. So let's just call that A. Let's call that B. Well, that's still B then, and we'll call that C. So A equals B and B equals C. So if A equals C and B equals C, and look at this. This is A and this is C. And then it says then A equals C. So that's very clearly the transitive property. And then the last one, everybody's like, oh my gosh, what is this negative 4e to the negative ti theta? That's a Greek letter. Oh, there's craziness. But don't worry, let's just call that A. And we multiply it by 1, we get the same thing over. So that's just the multiplicative identity. And if you have in your notes, I would go over all the different ones we talked about in case you see one. Anyway, those are all the problems on the review. If you have any questions on the review, come to class ready to go. Feel free to rewind and watch as many times as you need.